Okay, I just had to record this so that I can prove that I did it and have something to reference back to when I get ready to use this in this project or some other project. I got my digital resistors in today. Got a pack of 10 of them, and I set one of them up. That's this circuit here, and I got my 3 lines. It works on SPI interface. I got my 3 wires coming in to the far side of the chip. The far right hand pin over here with the red wire, that's your power going into the chip. The other 3 wires is your 3 legs of your pot. The center one being wiper, and then one on each side being the other 2 ends of the main resistor. I've got it wired up. This orange wire, that's hard to find. This orange wire that's jumping in is bringing your voltage into the pot. The other side of the pot I've got going to ground. It's a 10K ohm digital resistor, and then I'm coming off the wiper through a 470 ohm resistor going through this LED, and as I change the resistance, move the wiper from one end to the other, it'll vary how much voltage is going to the LED. Should change the brightness. Proof of concept. The main reason I got that 470 ohm resistor in there is they do warn about not wanting to pull more than 1 milliamp through the wiper, because that'll burn the wiper out. The wiper circuit. I don't think it's a physical wiper like you have on a pot. But anyway, here's the code that I wrote. And I looked it up, and I'm using the hardware SPI interface. So I didn't have to define any pins or anything like that. They're predefined. I enabled the SPI on the Pi so I can do this, and it made it so simple. I remember before doing an I2C interface and having to generate all the clock pulses and talk back and forth to make it do everything I wanted to do. And that was so aggravating. It was satisfying that I made it work, but it was just aggravating that I had to go through all that. But basically at the top, you're setting up your SPI. And then down here at the bottom, you only got one command to send to the pot, and that's that you want to write data. So the first 8 bits is your command, and the second 8 bits is the actual data you want to send, 00 through FF, which is your 256 positions of the wiper. And so I just got it where it runs from one end to the other with a 100 millisecond delay between each one. And then it closes it out. That's really it. So with that in mind, let me see if I can get out of this thing. Okay, and then I've also got it to display the number it's at. This is going to be tricky trying to do. I don't know how well you'll be able to see the LED, but it's this one right here. It should light up bright to start with and then gradually dim as the numbers go by. So let's go ahead and run it. And there it goes. It's slowly fading out. You can see on the screen the numbers going by. It's up to 100 now. It pretty much goes out before it gets all the way down to 255, but that's good. All right, there's 200. And then 255. And that was the full run of the digital resistor. And worked as designed. So that's the foundation for using that thing. Now just got to figure out how to apply it in the real world. Shouldn't be too hard, but anyway, that's one more step closer to wherever I'm going with all this. Talk to y'all later.